A senior security engineer does not treat STIX, TAXII, Sigma, YARA, and Snort as five random acronyms. Think of them as a detection language exchange. STIX describes threat intelligence in a structured way. TAXII transports that intelligence between systems. Sigma expresses log detection logic. YARA looks inside files and memory-like content. Snort watches network traffic. The job is to translate the same threat story into the right detection language for the right sensor. STIX is the language for describing threat intelligence. It can represent indicators, malware, attack patterns, identities, campaigns, relationships, sightings, and confidence. The important point is context. A bare IP address is fragile. A structured object can say what the indicator means, where it came from, what behavior it connects to, and how confident the organization is. For SecurityX reasoning, STX supports repeatable intelligence sharing, not magical truth. TAXII is the transport mechanism commonly used with STIX. If STIX is the structured message, TAXII is the delivery channel that lets platforms exchange those messages through collections and services. A threat intelligence platform, SIEM, SOAR workflow, or security data platform may use TAXIX to retrieve updates, but transport is not validation. SOAR workflow or security data platform may use TAXIX to retrieve UT, but transport is not validation. A senior ends backed is this VPI tightened. The bridge from intelligence to operations is translation. Intelligence may describe infrastructure, malware, exploited software, command and control behavior, or tactics and techniques. The detection engineer asks what observable signal would appear in this environment. If the signal is in logs, Sigma may fit. If it is in a file, YARA may fit. If it crosses the network, Snort may fit. Good engineering starts with observability, not with a favorite rule format. Sigma is best understood as a portable way to describe log detection logic. It is not a SIEM by itself, it is a rule format that can often be converted into platform-specific queries. That makes it useful for sharing detection ideas across environments. The engineering catch is field mapping. A Sigma rule only works well when your logs contain the needed fields, your parser normalizes them correctly, and your team tunes the logic for your environment. YARA is commonly used to identify file or content patterns. A rule can combine strings, byte sequences, metadata, and conditions to describe what suspicious or known malware-like content looks like. This is useful in malware triage, endpoint scanning, repository scanning, and retrospective hunting. But YARA is not a guarantee that a file is malicious. Broad strings can create false positives. Overly specific rules can miss variants. Precision matters. Snort is a network intrusion detection and prevention rule language and engine. Its rules look for packet and flow conditions such as protocol, ports, headers, content, and patterns in network traffic. It is strongest when placed where relevant traffic is visible and when rules are tuned to the environment. If the traffic is encrypted, routed around the sensor, or too noisy, the rule may not produce useful security outcomes. Imagine an adversary uses a phishing attachment that launches a script, reaches out to command infrastructure, and modifies system settings. STIX can describe the campaign and relationships. TAXIXII can distribute the intelligence. Sigma may detect suspicious process creation or identity behavior in logs. YARA may flag the attachment or payload pattern. Snort may detect a network pattern if traffic is visible. None of these replaces the others. They cover different evidence surfaces. The senior decision is not which acronym sounds best. Start with the intelligence, decide whether it describes an indicator, behavior, relationship, file content, or network pattern. Then choose the evidence surface that can observe it. Next, write or adapt the detection rule and validate it with known good and known bad examples. Finally, maintain the rule as infrastructure, versions change, and adversaries adapt. Detection engineering is a life cycle, not a one-time paste. Finally, maintain the rule as infrastructure, versions change, and adversaries adapt. Here is a realistic enterprise scenario. A financial services company receives partner intelligence about a malware family targeting remote access workflows. The intelligence arrives as STIX over TAXII with indicators, malware relationships, and a few behavior notes. The SOC does not blindly import every indicator as a high-severity alert. They translate the story. Sigma covers suspicious authentication and process events. YARA checks attachments and recovered payloads. Snort watches relevant network paths, whereas pass that sets kite. Quick decision check. A TAXIE feed delivers STIX intelligence about a malware campaign. The team wants one rule for SIEM logs, one for suspicious files, and one for network traffic. Which mapping best fits those evidence surfaces? Pause and choose the mapping that matches each tool to what it can observe. The strongest mapping is B Sigma belongs with SIEM-style log logic. YARA belongs with suspicious files or content patterns. Snort belongs with network traffic inspection. STIX and TAXIE still matter, but they are the intelligence description and delivery pieces, not replacements for the detection rule languages. The senior move is to preserve the threat context, then express it in the language each sensor understands. The final takeaway is simple. Build a detection language exchange, not a pile of disconnected rules. STX and TAXIE help move meaningful threat context. Sigma, YARA, and Snort express that context for different evidence surfaces. Security X level thinking asks whether the organization can validate the rule, tune it, version it, measure its coverage, and retire it when it stops helping. Knowing the acronym is entry level. Knowing the job of each language is the architecture skill.